Multiple linear regression in Python, absolute beginner lesson. Welcome! In this lesson, you will learn the basics of probability, descriptive statistics, and multiple linear regression using Python. By the end, you will understand how to apply regression to real-world data and explore relationships between variables. Let us get started. Running the cell now. This suppresses warning messages so your output is easy to read. Running the cell now. Probability, flipping a coin. Let us start with a simple probability example using a coin flip. Probability tells us how likely something is to happen. Running the cell now. We will use numpy to help us create random numbers. We simulate flipping a coin 10 times. Heads is 0, and tails is 1. This creates our data. We print the results of those 10 flips. Let us calculate how often heads appears. Probabilities are just how often something happens, divided by total trials. We print the probability we got heads. Running the cell now. Try changing the number of flips to 100 or 1000 and see if the probability of heads gets closer to 0.5. Descriptive statistics, summarize your data. Descriptive statistics help us quickly describe data using numbers like mean, median, and standard deviation. Let us work with some fun real data next. Running the cell now. Now we are going to use the miles per gallon dataset. Seaborn is a Python library that lets us easily load sample datasets. We import pandas for data analysis. Here, we load a dataset about cars and how many miles per gallon they get. We print its shape so we can see how many rows and columns the dataset has. Here is what the first few rows look like. Running the cell now. Let us find useful numbers that describe our miles per gallon column. This uses describe, which gives mean, minute, max, quartiles, and more. We print those numbers. Now we also find the median, which is the middle value if all numbers are sorted. We print the median too. Running the cell now. What is the difference between the mean and the median in your output? Sometimes data is missing. Missing data can cause errors if it is not handled. This checks each column for any missing values. We print that result. Then we remove rows where miles per gallon or horsepower are missing to keep our data clean. We print the shape of the clean data so you can see how many rows are left. Running the cell now. Probability distributions. Probability distributions help us describe how values are spread out. Let us simulate rolling a die using a discrete distribution. Running the cell now. Now we roll a die 1000 times, picking a number from 1 to 6 each time. We want to know how often we get a 6. We check how many rolls were 6, divide by total rolls, and print the probability. Running the cell now. Try rerunning the simulation. Does your probability of 6 get closer to 1 out of 6 as you increase the number of rolls? Let us see how miles per gallon values are spread using a histogram. We make a larger plot, with size 6 by 3. We draw the histogram. Each bar shows how many cars had miles per gallon in a certain range. We add a clear title. We label the x-axis to show miles per gallon. We label the y-axis to show how many cars we have in each bin. Now the chart will be displayed. Running the cell now. Exploring relationships, correlation. Correlation measures how two variables move together. Values close to 1 or -1 mean strong relationships. Values close to 0 mean weak or no relationship. Let us check how miles per gallon relates to horsepower. Running the cell now. We calculate the correlation between miles per gallon and horsepower. We print the result. Remember, negative means that as one goes up, the other goes down. Running the cell now. Linear regression, predicting miles per gallon from just horsepower. Regression predicts the value of one variable from one or more other variables. Let us start by predicting miles per gallon from horsepower using only one variable. Running the cell now. Statsmodels is a library for doing real statistical analysis in Python. We set our predictor as horsepower. We have to add a constant term so that the regression can fit an intercept. We set the target variable as miles per gallon. We use OLS, or ordinary least squares, to fit a line. We print a summary. This has a lot of info. Pay attention to what is under coef for horsepower and const. Running the cell now. Notice the R² value. This tells you how much of the miles per gallon variation is explained by horsepower alone. Multiple linear regression, predicting miles per gallon from several features. Multiple linear regression lets us use several predictors at once. We can use horsepower, weight, and cylinders to better predict miles per gallon. Let us do it. Running the cell now. We select 3 columns as our predictors: horsepower, weight, and number of cylinders. As before, we add a constant for the intercept. We fit the regression model using Statsmodels. We print the regression result summary. Look at the R² and coefficients for each predictor. Running the cell now. Which feature has the strongest relationship with miles per gallon in your output? Look at the absolute values of the coefficients. We use our model to predict miles per gallon for each car. We open a new 5x5 plot window. We make a scatter plot of actual values versus predicted values. Alpha controls the transparency of the dots. We label the real miles per gallon on the x-axis. We label our model's prediction on the y-axis. We add a title so it is clear what we are comparing. The red dashed line shows where a perfect prediction would land. Now you can see how well our model does. Running the cell now. Does the model do a perfect job? Where do predictions miss? What patterns do you see? It can be a problem if predictors are too closely related. This is called multicollinearity. We use variance inflation factor to check each column. We create a table showing which predictors might have a high VIF. If you see VIF values greater than 10, it can be a sign of trouble. Running the cell now. Let us make a prediction for a car you choose. You will type a horsepower value here. Now type the car's weight. Next, enter the number of cylinders. We create a data frame with your answers to input to our model. The model predicts the miles per gallon value for this set of features. We print the prediction. This is the estimated miles per gallon your car would get, based on the model. Running the cell now. Try a few different combinations for horsepower, weight, and cylinders. How does the prediction change when you change one value? Best practices and troubleshooting. Always check for missing data and outliers. Keep an eye on multicollinearity using VIF. Try different models and be sure to visualize your results. If your predictions do not make sense, double-check your data and calculations. Running the cell now. To practice, try leaving one predictor out. Here, we fit a model with just weight and cylinders as predictors. We add a constant like before. We fit and summarize the model. See how this changes R-squared and the coefficients. Running the cell now. Try different combinations. Which predictors work best on their own? Challenge exercise. Build a regression model to predict miles per gallon using horsepower and acceleration. How does the R-squared value compare to your model with 3 predictors? Try visualizing the predictions too. Running the cell now. Share your answer in the comments, and if you enjoyed this video, please subscribe to the channel for more Python lessons. Recap what you learned. How to load and clean real datasets in Python. How to calculate descriptive statistics, visualize distributions, and check relationships. How to build and interpret multiple linear regression models. How to predict new values using regression. Keep practicing and you will master these skills. Running the cell now. Thanks for learning multiple regression in Python. If you found this helpful, like and subscribe to the channel for more beginner data science lessons. See you next time. Running the cell now.